Is my voice is audible to you? I hope my voice is audible to you and everything is working well for you, right? So, uh, let me let me have a look. If you are in online, please say hi so that I will understand, right? Okay, 1 second. Let me have a look here. Vasant Sai, hi sir. Hi Vasant Sai. Is my voice is audible to you? Vasant Sai, right? If my voice is audible, say yes, sir. Okay? Right. If everything is fine. Okay. I hope my voice is audible and everything is working well. So, coming to today's session, right? Today's session is on footing second part and and columns first part. So in this today's session, we will work out the problems on footings, and after that we will tackle the theory and some problems on columns. We will start. Yes, and before I start the session, I just want to convey you uh, one more thing. Like there are so much of free content is already happening in Unacademy Learning app. So if you didn't install this Unacademy Learning app, then I can recommend you guys to install this one because free content is there and also paid courses are also there in Unacademy Learning app. And moreover, if you are want to follow me in Unacademy Learning app, use this link which is given below so that you are able to follow me. Right. Some some people will say, sir, how to take the paid courses in Unacademy, right? So after you install the Unacademy Learning app, set the target as your competitive examination, especially whatever you want to crack. This is the target what I want to achieve, like GATE and ESE. After you keep this as GATE and ESE, in the main drop down menu, go to plus courses. After you go to plus courses, after you go to plus Unacademy plus, Unacademy Plus in main drop down menu, right? So you are able to see a tab called Get Subscription. When you press on this Get Subscription, you will be shown with two courses. One is Iconic and second one is Plus course. When in Iconic, the extra thing that we are providing is in addition to notes, we are also providing a personal mentor to you to solve all your doubts. So plus personal mentor to solve all your doubts. Whereas in case of plus, we will teach all these things. Maybe for I can say all you instant doubt resolution is there, and I can say test series support is also there, and all the courses are structured courses. You will be provided access to all the courses that are provided in an academy learning app. And fourth one is you will be provided unlimited access to all the lectures in the form of live and also in the form of recorded version. These are the important features in plus. So but in iconic, in addition to the plus features plus extra, these two will also come. So this iconic is more productive, I can say, right? For any of the course, whether for iconic courses or plus courses, to get 10% discount, you need to use this code VT10. When you are bound to use this code VT10, directly 10% discount will always come in all the courses on an Academy Plus platform. Right. Some people will also say like, sir, okay, what I will get if I had taken this plus course or plus subscription? After you get the plus subscription, you will be given access to unlimited live and recorded courses from India's best faculty. So what are how many number of courses that were launched in your particular stream? In all those courses, for all those courses, you will be provided access, right? And some people will also say, "Sir, can you please introduce yourself? Because this I am new to this platform. This is my first lecture." Some people will also ask. So coming to myself, I am Venkata Tilak. People call me as people call me as Venkata sir. Some people call me as Tilak sir. I completed my master's degree from University of Sheffield, England, and about to complete my doctoral degree also, which is PhD. My background of education is completely into structural engineering. So here also in an academy, I am going to teach only the structural engineering subjects. ranging from engineering mechanics, strength of materials, structural analysis, concrete structures, steel structures, and finally to construction materials and management. These six subjects I am going to tackle, brother. Right. Some people coming to this university from where I had graduated. This university has produced six Nobel Prize winners. You can understand producing six Nobel Prize winners from a university is not a joke. You can understand one thing. And moreover, about this university has this university ranking is always less than 100 globally, and which is far better than IITs and IIC Bangalore. It is not told by me, it was conveyed, or it was confirmed by all the ranking ages in globally. And I just want to convey one more thing. Coming to my previous work experience, other than teaching experience, I worked as research scientist or research engineer in University of South Carolina. This is in USA. And also for that project, for that research engineer in University of South Carolina, I worked as team leader for for that funded project also. Moreover, I already worked as head of the Department of Civil Engineering in STEM College, which is in India or in Andhra Pradesh, India. So that I have, though I want to convey, I have both local experience and global experience also. Being a structural engineer, even till today also, I am working as an independent structural design consultant. I personally provide structural drawings to my clients. I personally provide structural drawings to my clients and material testing reports to my clients. Coming to my teaching experience, totally I have 12 years of teaching experience in teaching GATE and ESE in different coaching institutes all across India. This is my brief background, brother. I had mentored lakhs of students till now. Now, some people will also ask us, sir, okay, sir, you asked us to install this Unacademy learning app. Na? How to install that one? Go to Play Store and type this name, Unacademy learning app. When you type this name, Unacademy learning app, you are able to see a championship type of trophy in this way logo. For that app, you install that one. When you install the app, you are able to see a screen on the right hand side which is shown in this way. So there are two questions are there. Question number one is, sir, how we can follow you from this one? How to follow you? How to follow? The question is, go to here in the main drop down menu, go to free courses. I hope you know free courses in this main drop down menu. After you go to free courses, in the search button, you can type my name, complete name, Venkata. Uh, I hope you can see Venkata Tilak Uppalapati. When you type this name and when you press enter, then obviously my profile will be visible to you. You just follow me. When you are able to follow me, the advantages are the free content done by me that you are able to access. Second advantage, the upcoming free video lectures of mine will be notified to you. That is second advantage. Third advantage, at the end of each and every free class, we will provide a PDF notes to you. You are able to access even that. So all these three for free of cost you are able to get at least, right? Some people will say like, sir, okay, I want to take the paid course. How I can take the paid course with the help of the screenshot? Can you explain? Yes, I hope after you take this target as GATE and ESE, this is the target or goal what you want to achieve. Okay, you keep this same, but here in this main drop down menu, go to plus courses or Unacademy plus. After you go to Unacademy plus, you will be able to see called get subscription. When you press this get subscription, there are two paid things are there. One is plus course and second one is iconic. Whatever may be the course that you are interested, you can pick that one. And if you want to get 10% discount for any of the courses, plus courses or iconic courses, you are bound to use the code VT10. Then 10% discount will directly come to you on all the courses, right? Some people will also ask us, sir, what are the advantages in taking a paid course. The first and foremost advantage is instant doubt resolution is possible when you had taken a paid course, paid subscription, brother, where the free subscription student doesn't have. Right. Second advantage is in order to crack any sort of competitive examination, support of test series is there. Here also in Unacademy, we are providing test series support. We are providing test series support. Using that test series support, you after writing the test, you will understand at what level you people are performing when compared to the topmost students of an academy, and you can understand your performance. If you want to increase your performance, definitely you can improve the performance in that particular subject by listening to more number of lectures and by working out more number of problems, right? So coming to the third advantage is there is no need to plan yourself. We will provide the entire plan because all the courses that are provided by Unacademy are completely structured courses. We will plan the courses in such a way that even the below average student can cope up with our lectures. We will not compromise with respect to the number of hours, so that even the below average student can cope up with our lectures, brother. And in that structured course, if you are able to complete all the video lectures in detail, and if you are able to solve all the test series questions, maybe test, live test, mock test, grand test, subject wise test, then pretty we are pretty much sure like you are able to get a pretty good rank. There is no doubt at all. Coming to the fourth advantage is, let us suppose on one or few days some students may not be able to come down to live. In such case, they will be provided access with the recorded form of version of the same lecture through any comfort of their devices like mobile phone or maybe tab or maybe PC, depending on their comfort. And the access will be provided for unlimited access, maybe for 1 year or 2 years, depending on the duration of subscription you had taken. Right. These are some of the topmost indicators that you have. You can have a directly look in the app itself. And coming to the courses that are there in an academy, the courses will be taught separately in English and the courses will be taught separately in Hindi. So there won't be any language barrier also, especially even to South Indians also. So if you are comfortable in English, you can sit in English classes. If you are comfortable in Hindi, guy, you can sit only in Hindi classes. But when you had taken subscription, you will be provide access to all the medium courses in your particular stream, right? And some people will also ask us, sir, in GATE and ESE, till now in civil engineering, how many courses you people had launched? Till now in GATE and ESE, we people had launched 8 courses. Out of these 8 courses, few courses are in English, few courses are in Hindi. Few courses are long-term courses, few courses are short-term courses. When you have taken subscription, you will be provided access to all the courses that are launched, that are being launched within the duration of subscription that you had taken, right? And to take a 10% discount, don't forget to use this code VT10, brother, right? And I just want to convey one more thing, like for a, coming to the price for plus subscription. Okay, for plus subscription, the courses are from 1 month course to 24-month course. So if you are a final year student, I can recommend you guys with this 12 months course, which is costing around 27,225 after 10% discount. If you are a third year student or second year student, that I can definitely recommend you this 24 months course, brother. In such case, the cost after 10% discount, after using this referral code VD10, the cost is 39,600. So I just want to convey you, even there are other duration of subscription of courses are there, just like tailor-made. You can use those courses also. But this is my recommendation. This course for the final year and this course for third year and second year students I can convey. Hi Rahul Soda Dasi. How are you? Good morning. Good morning, brother. And why I want to convey you every day. My class is happening in Let's Crack Gate and ESE Civil YouTube channel. Every day my class is happening by 11 a.m. You can come down to my class every day by 11 p.m. 11 a.m. Sorry, not 11 p.m. 11 a.m. And I am teaching structures in this platform, right? Some people will also, I just want to convey one more thing. You are getting all these lectures for free of cost, so please subscribe to this channel and please share these videos to your friends, brother. At least they will get benefited by this free content, isn't it or not? And one more thing is, I can recommend you to share, I can recommend you to subscribe to our Telegram group also, because I had started this Telegram group so that whatever maybe the doubts you have, you are able to post your doubts directly in that Telegram group. And the name of that Telegram channel is Unacademy underscore Civil Engineer Tilak. And if you want to come down to that channel, use this link which is given below. If you are able to use this link which is given below, then if you are able to come down, you can post your directly your doubts or whatever that may be. You can post directly in the Telegram group. I will take care of your doubts, right? This is what will happen, right? Some people will, and I want to convey one more thing. Please raise a thumbs up, please share our videos, please subscribe to our videos. Please don't forget to press the bell icon. If you press the bell icon, the future upcoming videos lectures will be notified to you. If you want to take the paid course in Unacademy Plus, then you please don't forget to use this code VT10. This is very much important. If you don't use this code, definitely you need to pay 10% extra. Right? Shall we start the questions, brother? Rahul Sodashi, right? Vasant Sai, Rahul Sodashi. Shall we start the questions? Right? I mean the problems. What are the problems in footings? Shall we start? Yes, these are the problems in footings. I hope you are able to see this question. Can you see this question, Rahul Soda Dasi? I'm giving you 1 minute. In the meantime, please go through that question and I'm expecting answer from you. Coming to the theory, I had already completed a theory in detail with reasoning in your previous classes. Okay, in your previous session, I completed a theory with the details, with the reasoning, everything with the help of sketches, everything I had completed. I just want to check whether you are, after teaching that theory, are you able to solve these problems or not? So that's what I want to check. Okay, shall we start? I hope Rahul Sodalasi can try. You people can try. In the meantime, let me work out so that I'm here to teach. Yes, no doubt at all. But I need to support you at each and every level. As I already teach you theory, I'm expecting from you guys the answer. Anyway, I will always solve these problems. It's not at all a problem, right? Yes. Right. Coming to the question, a square type of pad footing in the sense that footing is a prismatic footing, that cross section, the thickness of the footing is constant. Footing of size 3.5 meter in size is designed to support a square column of 450 millimeter size. So let me take a pad type of square footing. Okay, let me take a pad type of square footing. Okay, I had taken, this is a square footing. What is the size of this square footing, brother? This is in plan. This is 3.5 meters. This is 3.5 meters. Over this slab footing or square footing, a square column of 400 millimeter size. That is the size of the column. How much I can show you, brother? The size of the column is uh, zero point 0.4 meter, right? So maybe I can say this is zero point 0.4 meter. This is 0.4. It was taken in this way. The effective depth of the footing is 560 millimeter. So they are saying the effective depth of the footing, small d, is 560 millimeter. So please be aware of that. The safe bearing capacity below the footing. So the safe bearing capacity, which we people call it as Q naught. Q naught, which is the safe bearing capacity below the footing, is 122.4 kilopascal. Pascal it is Newton per meter square. Kilopascal is kilonewton per meter square. Right. So in this case, the depth is 0.56 meter. I can write. Okay. Now the question is the loads. This pressure is based on ultimate loads. Okay. For one-way shear force, design for one-way shear. Find the design shear force. What is the one-way? What is the design one-way shear force and nominal one-way shear stress? That is the question that they are expecting. And generally, this one-way shear force will always fail towards the least direction. So out of 3.5 and 3.5, the least direction can always be, can be any direction. If I take the least from the face of the column, the one-way shear will happen at a distance of effective depth D from the face of the column. If I take this distance is effective depth from the D of the column, you are able to see this is how the section is. This is the critical section for one way shear, right? If this is the critical section for one way shear, if this is P, if this is L, how to find out the critical section for one way shear? I can say this hatched portion will come up. This is in plan. I just want to convey you, right? If I want to show you the same thing in top view, maybe I can show you like this how. Isn't it or not? Just to make you understand, I am teaching with complete explanation, right? This is the critical section for one way shear. I can write critical section for one way shear. If it is the critical section for one way shear, now you tell me if this is the case, what is this what is this design shear force? How you can say that design shear force, brother? The design one way shear force. How you can write that if the design one way shear force Vu is equal to one way shear force? How I can work out? It is this pressure from the bottom. I hope you can say this is Q naught, right? This is Q naught. So I can work out directly as this Q naught multiplied by, if I take the free body diagram of left hand side of this critical section XX, then the shear force will exist on this critical section XX, and the shear force one way shear force is that bearing pressure distribution from the soil on the footing multiplied by the area of this hatched portion. Maybe the area of this hatched portion, maybe I can take as A naught. It's up to you. I can take it as A. So if I take it as A naught, then I can write this as Q naught is how much, brother? The value of this Q naught, I can take it as 122.4 kilonewton per meter square into A naught. How you can work out this A naught? This is breadth. Breadth is 3.5 into this is L. Na? I need to work out L. Now the question is how to work out that L. Can you work out this L, brother? Yes, this is already 3.5. 3.5 minus zero point 0.4 by 2. I can write this L is equal to 3.5 minus zero point 0.4 by 2. From that one, I need to deduct the effective depth. That the effective depth is 0.56 meter. So minus 0.56. If you work out this one, you will end up with 0.99 meter. So let me write here this length L. This L as, one second. Let me work out this L as 0.99. So the answer will be definitely in terms of kilonewton, and coming to the answer in kilonewton, it is 424.116 kilonewton. Just by with this answer, you are able to pick option B is the correct one. But I had worked out only this one, right? And I need to work out this value. How I can work out the nominal shearing stress? So can I work out the nominal shearing stress, brother? So let me show you how we can work out the nominal shear stress, right? So coming to tau v nominal one way shear stress, I can write nominal one way shear stress. If I do this one, generally this can be worked out by one way shear force by the shear area over which that one way shear is developing. The one way shear is developing on a depth of effective depth D, and it is acting over a width of this P. So I can write B times of the depth of the effective depth of the footing at critical section, right? So I can write B times of this maybe DC, right? Here I can write which is VU by B times of DC. Is that okay? Now coming to VU, what is the value of VU? 424.116. Can I say this is in kilonewton divided by the width B? It is 3.5 meter into DC, depth of the depth of the footing at critical section where one way shear failure is happening. That is the effective depth, right? The effective depth is 0.56 meter. If you take here, the answer is 216.38. I can say kilo Newton per meter square. So we can write it as 216.38 kilo Pascal. If you can say here, the question here, if you take this answer, it is in megapascal. How to convert kilopascal into megapascal, right? So how we can write this kilopascal into megapascal, brother? So megapascal. So it is kilopascal in sense. We can directly write 216.38 kilo in sense 10 cube. Pascal means Newton per meter square. If I want to get megapascal, then I require 10 to the power of 6. So to work out 10 to the power of 6, multiply this by 10 cube and divide this by 10 cube. So the answer will be 0.21638 into 10 to the power of 6 Newton per meter square. So I can write as 0.21638 10 to the power of 6 Newton per meter square. It is kilopascal, right? So sorry, it is so it is 10 to the power of 6 Newton per millimeters, Newton per meter square. I can write it as megapascal. Yes. I can write it as directly megapascal. Megapascal. Newton per millimeter. This is how we are able to work out. Right? So we can pick option A is the correct one. Sorry, sir, option B is the correct one. Is that okay? Shall I move to the next question, brothers? Is that okay? Can I move to the next question? Right? So moving to the next question. So can you see this second question? A square pad type footing, 3.5 meter size in size. It is a square footing is there, and the size of the square footing is 3.5 meter in size. Okay, let me take a square footing. Okay, I had taken a square footing of 3.5 meter in size is designed to support a square column of 400 millimeter size. So I think the problem is one and same, the same previous problem. The data is one and same, but the question that was asked for the data is different. This is zero point 0.4 and this is 3.5 meter. Right? The effective depth of the footing is 560 millimeter. So what is the effective depth of the footing? 1 second. The effective depth of the footing, the effective depth of the footing is, it's a pad footing they are saying. When it is a pad footing, it is a prismatic footing. That means the depth is not at all varying. So please understand. Yes. Ash, Ashutosh Jaina, I have a doubt. I want to ask. Yes, you are free to ask, brother Ashutosh Jaina. Yes, sir. For GATE 2020, which parts of RCC should be focused upon? Okay, good question. For RCC, whatever the things that I am teaching, you can focus that one. Like limit state. See, from limit state of flexor and from limit state of shear. Definitely, a 2 mark question is damn sure, right? And moreover, from pre-stressed concrete, if you see, definitely a question is damn sure, right? And from limit state of limit state of compression and limit state of these footings, so footings and all these things, another 2 mark question will definitely come, right? So these are the important topics, brother Ashutosh Jena. Is that okay, brother? Yeah, don't worry, brother. Whatever may be the doubt, if you have, you are free to ask. There is no problem. I am your brother. If you had any doubt, you can ask us. This is my problem. Can you answer that? Yes. Thank you very much. So shall I work out this problem? Yes. This is also required, right? So coming to this one, the effective depth of the footing. So what is the effective depth of the footing, brother? The effective depth of the footing is 560 millimeter. And the effective depth of the footing, which is small d, is 560 millimeter. How I can write 560 millimeter in terms of meter? 0.56 meter. Right. Okay. The safe bearing pressure, which we people call it as Q naught, from below the footing is 122.4 kilopascal, which is kilonewton per meter square. It is nothing. Kilopascal. I hope you know 1 Pascal is 1 Newton per meter square. Kilopascal is kilonewton per meter square is kilopascal. Okay, for getting grade up app, should it will be helpful to me. Dear, it is not just few things. I can say you need to work out more and more. I just want to say like you need to work out more and more, brother. Astos Jena. Okay, you need to work out more. I mean, the thing is, the confidence is the key here, brother. So, is that is sufficient or not sufficient? That depends on you. If you are good in concept, then everything is sufficient. If you are not good in concepts, then you need to work out more number of varieties of problems. That's how we can say, brother. Okay, right. Hi, Devarpalli Surya Prakash. Fat Marathon series. Now I am able to work out the problems. Okay, okay, brother Ashtosh Jaina. Okay, okay, good, good, good. Okay, right. Right. Okay. And I just want to convey you, Ashutosh Jaina, I had teach you in detailed series. I mean, most of the important things for steel structures, for concrete structures, and for essay, I had already covered in YouTube. For these important things, important models, I had already covered for in this Unacademy, in this Let's Crack GATE and ESE. Maybe from the past 3 months, I am working out these important things. I mean, the most focused things. Okay. So you can just after this session, you can have a look at them also. That will definitely fetch your preparation. There is no doubt at all. That will definitely fetch your rank. Right. Okay, let us work out this problem. Okay. So, okay. The thing is, I need to teach you the problems or maybe the subject. Okay. So, let's stop this small discussion and let us focus on this question. Okay. Right. Good. The question is okay. Right. The state bearing pressure below the footing is 122 kilopascal based on ultimate load. So they are saying this is the pressure. Just to make you understand, I am teaching everything in detail, but we can work out all these problems very quickly, which is 122.4 kilonewton per meter square. What I teach you for two-way shear, to work out the two-way shear force, the design shear force and nominal shearing stress. What is the design shear force, two-way shear force? The design two-way shear force will exist in the two directions, right? The failure of two-way shear will happen in both the directions, both longitudinal direction and also in lateral direction in this way. And at what distance it will happen? It will happen at a distance of d by 2 from the face of the column. It will happen at a distance of d by 2, right? So if you take this is the way how the crack will happen, right? And if I want to show you here, this is how the crack will happen. If you can say this panel will go down, this will go down, whereas these two will come up because of this punching shear or two-way shear, right? Now, if I want to work out, now how you can work out this two-way shear force, brother? To work out this two-way shear force, the answer is very simple, brother. This is the hatched portion. Maybe if you refer to my previous theory background thing, in the theory background thing, I already mentioned this is some area. If you are able to work out that area maybe I can take as A. The hatched portion area is A. And if you want to work out this VU stands for the two-way design two-way shear force. Design two-way shear force and a design two-way shear force. How we can work out the design two-way shear force? It is definitely the stress Q naught into this hatched portion area. Please understand this hatched portion area in plan. The hatched portion area in plan is A. This is in plan. This is in front view. Is that okay? Right? This is in plan, this is in front view. Now, can you work out the Q naught is already known, which is 122.4 kilonewton per meter square. If you are able to work out this hatched portion correctly, somehow from the geometry of the figures, the problem is over. The hatched portion area A. How to work out this hatched portion area A? Maybe the bigger rectangle which is outside minus inside a small rectangle. I hope with this dotted portion, that area minus the outside big square minus inside square area. If I remove, if I do, then I will get this area A. So what is that outside outside a square area, which is 3.5 square, minus inside square. This width is already zero point 0.4. This is already d by 2. This is already d by 2. So this is zero point 0.4 plus d. Will you accept this? Will you accept this as zero point 0.4 plus d? Maybe I can show like this is definitely zero point 0.4 plus d. And this is also definitely, no doubt at all, this dimension is also zero point 0.4 meter plus d. So I can say minus zero point 0.4 plus d into zero point 0.4 plus d. It is zero point 0.4 plus d square, right? Can we write in this way? And if we do in this way, we are able to work out this answer. Now coming to this d, what is the answer for d, brother? We can say the answer for d, how I can work out the answer for d is, it is 0.56 meter. So keep here d as 0.56 meter square. If you do this answer, this is meter square will get cancelled. The answer for this design two-way shear force will be definitely in kilonewton. Now the question is, every of my brother, especially Ashutosh Jaina, will ask us, sir, what is this answer for? What is this answer in kilonewton? This answer in kilonewton is 1386.596 kilonewton. So just by looking at these options, you can pick option C just with the help of one and only one option. The first option is 1386.5. The nearest answer is 1390. So you can pick directly option C. But I want to show you how we can work out even this answer, which is the two-way shearing stress. The first question is, there are two questions for there. The first question is design shear force is question 1, and second question is nominal shear stress. Because of this two-way shear, what is the nominal shear stress or average two-way shear stress or punching shear stress that they are expecting? This first answer is over. If you please excuse me, can I work out the second question in the same problem? In the same problem, can I work out the second question? Is that okay, Ashutosh Jena? Can I work out the second question? Yes. Okay, I just want to work out the second question. To work out the second question, maybe I am just erasing here itself. Yes. Here in this space I will work out the second problem. So that's the reason why I don't want to go to the next slide, because if I go to the next slide I need to draw this sketch again, which will make us difficult, right? So I am just rubbing this answer of the first bit. I am working out the question here itself, the second bit. So coming to the second bit, how they are expecting tau v. What is this tau v? The average shearing stress, which is equal to vu by the area over which that shearing stress is developing. The area over which that shearing stress is developing is, I can say, the perimeter of this dotted line, which we can call it as perimeter of this dotted line. I hope you are able to see. Uh, this is the perimeter of the dotted line. This red line. This is the perimeter. This over this perimeter length that two-way shear is developing, and a two-way shear is developing over a depth of dc, right? Over a depth of dc. So I can write p times of dc. Now coming to vu, I hope you know what is the answer of vu, which is 1386.596. This is in kilonewton divided by perimeter. Now can you tell me what is the perimeter? The perimeter for one side, it is 0.4 plus d, right? For one side, how many such sides are there? 1, 2, 3, 4. So the perimeter of this dotted thing can be written as 4 times of 4 into zero point 0.4 plus effective depth. That effective depth is 0.56. This is perimeter, right? Into, I need to work out depth of the footing at critical section. What is the depth of the footing at critical section of two-way shear? I just want to convey here, or I want to write, this is the critical section for, this red line is the critical section for two-way shear. So I can say DC, the value of the DC is 0.56. Right. So this is how, if you can take this bottom will be in terms of meter square. You will get this answer definitely in kilonewton per meter square. Kilonewton per meter square means kilopascal. It is 644.8 kilonewton per meter square. So if I want to work out the same thing in terms of megapascal, I can write this divided by 1000. Then in such case, it is 0.644 megapascal. Megapascal I can write. So this is how we can work out. So the option is option C directly we can pick. So Ashutosh Jana, can I move to the next slide, brother? Right? Can I move to the next slide? Right. Right. And coming to the third question, are you? I hope you are able to see this question, brother. Right? Can you see this question? A square pad type footing 3.5 meter in size is designed to support a square column. Okay, to support a square footing is there, and it is supporting a square column. And the dimensions are also just like that of same, just like that of your previous data. That means data for question 1, question 2, question 3 are one and same. But the question that was asked from the data is different. Okay, the effective depth of the footing D. Okay, the safe bearing pressure. Okay, based on ultimate loads. Okay, they are expecting what is the design bending moment. So what is the design bending moment for this problem? Right, the problem is one and same, but the questions that were asked from the data is different in question to question. Right. So first of all, you tell me what is the critical section for bending moment. Critical section for bending moment is always at the face of the column, right? In case of rigid jointed structures, right? So can I take this as a square or pad footing? Yes, I can take this as square or pad footing. Okay, I had taken. After I take this as square or pad footing, right? What is the dimension of the square footing or pad footing, brother? This is 3.5 meter by this is 3.5 meter. Okay, right. And you are able to take a square column, and the square column is zero point 0.4 zero point 0.4 meter size. So this is a square column of dimension zero point 0.4 meter. This is also zero point 0.4 meter. Okay. The safe bearing pressure, maybe I can say, if I take this is the column and this is the footing and it is a pad footing, so that's the reason why I should say it is a prismatic footing only, it is not a tapered footing, right? And here, if you take, this is the bearing pressure from the bottom. If this is the bearing pressure from the bottom, what is that answer, brother? That answer is Q naught, and Q naught is 122.4 kilopascal, which is kilonewton per meter square, right? The design bending moment in kilonewton meter. What is the design bending moment here? Now you tell me from your previous theory in your last class, what where the design bending moment for where the design bending moment is possible in case of footings at the face of the column. Here, as the dimensions, this dimension is 3.5 and this dimension is also 3.5. In both the directions, the bending moment will be one and same. There is no doubt at all. Let us suppose if I take the critical section for bending moment is at this one. This is the critical section for bending moment. This is the critical section for bending moment. The critical section for bending moment is always existing at the face of the column. Okay. Now, how we can work out this bending moment here? This pressure multiplied by, if I take the freeboard diagram of left hand side of this critical section. This is the area that is in plan, right? This is in plan. This is in front view. This is in plan and this is in front view. Is that okay? Now, after this, now can you please tell me, right? Can you please tell me what is the bending moment exactly at this section? The bending moment exactly at this section is, I don't know, I can take it as mx. What is that value of mx? Mx is equal to this pressure Q naught multiplied by this area. Maybe the area that I can take as A. This area is A, so I can write this is the point force. This is the point force. How that point force will act from this critical section? The point force will act at a distance of this value divided by 2. What is this value? Obviously, This value is already 3.5 minus 0.4 by 2. So I can say if I take this distance is x bar, for example. If the distance of this if the distance of the centroid of this force from the critical section is x bar, if I want to show x bar is 3.5 minus zero point 0.4 by 2 by 2 is divided by 4. So which will be x bar, we can write as 0.775 meter. So can I work out bending moment with respect to x or bending moment with respect to y? The answer is q naught into a into x bar. The answer for this q naught, which is 122.4 kilonewton per meter square into area. What is that area of the hatched portion? The area of this hatched portion is, this is already maybe I can say 1.55. This dimension. This dimension from here to here, from here to here, this is 1.55 meter. So that area of the hatchet portion is 3.5 into 1.555 meter. 3.5 meter into 1.55. This is the area into x bar. But x bar is 0.775, na? 0.775. If you do this one, definitely we are going to get that bending moment in terms of kilonewton meter, right? So what is that bending moment in terms of kilonewton meter, brother? Which is 514.615 kilonewton meter. This is how you can work out. So I can say definitely it is 514 na. So I can say the nearest option is 515. Right? This is the correct option. 515 kilonewton meter. They are expected the units are directly in kilonewton meter. That's the reason why directly you can pick the option as option A. Is that okay? Dear Ashutosh Jaina, Devarapalli Surya Prakash, right? Vasant Sai. Can I move to the next problem? You please excuse me. Moving to the next problem. Is that okay? Yes, let me move to the next problem, brother. I hope you are able to see this. This question is a concept of both, I can say, footings plus columns plus the concept of strength, total stress concept from strength of materials. Total stress concept from strength of materials. Dear, just after I complete this, dear Ashutosh Jaina, after I complete this RCC, maybe the next month I will start PSC. Next month I will start PSC, brother. Pre-stressed concrete questions. Okay. So maybe I can say M, which is 60 kilonewton meter at the base. The isolated footing, an isolated footing of 2 meter by 3 meter. Okay, one is 2 meter and 3 meter with 3 meter side, with 3 meter side along the plane of bending. So if I take this is a column, that column is taking a load of this PU and some bending moment in this way. Yeah, and this is how the footing. What is the plane of this bending? The plane of the bending is with the 3 meter side along the plane of bending. This plane of bending is along with the 3 meter side. That means this may be 3 meter definitely. And this is in front view. I can write. Sir, I have only read working stress method, shear, and 60 PSC. So what is okay? But you need dear, especially for GATE. For GATE, I just want to tell you, dear Ashutosh Jaina, you need to emphasize more on limit state method for GATE. If it is the other exams like ESE or maybe JE exams, JE exams, SSC JE exams, in such case, some questions are will be asked for working stress method. But if you take GATE, most of the questions will be asked from limit state method only, LSM, 95 percentage, more than 95 percentage probability. The questions, if you see, after 2000, most of the questions were asked only from limit state method for GATE. Okay, as you are talking about GATE. For other PSU examinations like ESC, in such case, there is a chance they are even asking working stress method also, right? So please fix your concepts even in limit state method. Okay, please understand that. And for limit state method, I had worked out each and every model, each and every topic. I mean, the important models. Don't think like I had completely done. No, no, no. So to work out to completely done, it will take a lot of time. I had taken sufficient time for within this 2 months. What is the important, or I can say, what are the focusing things that I can do? That focused things I had done there. So you can go through that. Okay, right? Okay, Ashutosh Jena, right? Yeah. Right. So this is the question, and don't worry, brother. I had teach the theory, and after that only I solved the problems. So don't worry, you will understand everything in detail because I had teach the theory and with reason. With if there is any derivation is there, I had done that important derivation, and then I had taken the questions. Okay, so you will work out for. Don't think like it is everything is covered. Important concepts, important things were covered. Most emphasized concepts, which are damn sure things. Those damn sure things were covered here. Okay, right. So if this is the case, now everybody will also ask us, sir, this is PU, this is M. This bending moment is acting along the plane of this 3 meter side. This is in front view. Okay, how I can show the same thing in plan, brother? I just want to show in plan. This is having one dimension is 2 meter, another dimension is 3 meter. This is 2 meter dimension, and this is 3 meter dimension. This is how the sketch is. And it is heavy, it is carry it, there is a column is there. Maybe I can take, there is a column is there. Okay, this is how the column is. Now what they are saying, the center of gravity, this is 3 meter, this is 2 meter. What they are saying, brother, the CG, the center of gravity of the footing, the CG of the column and the footing are coinciding. The CG of the column, this is the CG of the column, centroid of the column. This is the CG of the footing. Both are coinciding. When CG of the column and CG of the footing are coinciding, no extra bending moment will come. Now they are expecting the net maximum and minimum stress pressure in kilonewton per meter square on soil under the footing. So because of this axial load, some P by A stress will come. Because of this bending moment, M by Z stress will come. So I just want to convey you, there are, if you take on this side maximum stress, I hope from the concepts, you know, the you learned the concepts of SOM. From the concepts of SOM, you know the maximum stress, comma minimum resultant maximum stress and minimum stress. How you can work out it is P by A plus or minus M by Z. Like that, we are able to keep. Is that okay? Right. Right. Dear sir, actually I'm starting SOM and SA. Dear, first of all, you work out strength of metals and you come to SA, right? Yes. So that I will be, yes, that is the basic stuff. If you don't know that basics, then first of all, to design, you need to know what are the critical forces. You need to know. So otherwise it is difficult for you, right? 1 second, brother. Yes. Right. So can you work out this one? If you take this sum, then this is the resultant stress or net stress. It is the combination of P by A, in sense it is the combination of axial stress and the stress due to bending. This is because of bending moment, na? So plus or minus bending stress. I hope your SM teacher might had already teach you axial stress is, this is resisting force by area over which that stress is developed. The stress Q naught is developing over this area of 2 by 3 meter. Na? So if you see, this is how the maximum stress is possible on the right hand side, whereas minimum stress is possible on the left hand side, because how the moment is there, the moment is there in the clockwise fashion. So here there is a possibility of tension, there is a possibility of here compression, right? So coming to, this is sigma max, this is sigma minimum. What is the formula for sigma max? I need to use plus here. Here in this one, I need to use plus for sigma max. To get sigma minimum, I need to use minus. That is the only way, right? So can you work out the sigma max, brother? Yes. So shall I work out this with the sigma max? I just want to say, what is this area? Area is 2 by 3 meter, not 2 by 3 meter square. And coming to Z, What is the section modulus about the axis of bending here? What is the axis of bending, brother? Here this yy. If I take this is yy. About this yy axis, this bending moment m is there. So the z I need to consider about this. About this chosen yy axis, z about yy axis. What, how I can work out section, elastic section modulus about this yy axis? That is bd square by 6, and the value of b is 2. Bd square by 6, b is 2. Parallel to this axis, it is dimension is 2, d is 3, so it is 3, bd square by 6. This is how I can work out z by y. Just let me substitute directly in this formula. Is that okay? So can I use the next slide to substitute directly in this formulas? Is that okay? Right. So coming to this formula, if you come to sigma max, the answer is P by A, na? So it is 450. I can say the question, the formula is, sorry, the data is directly in kilonewton, and the area is in meter square. Na? So can use here 450 kilonewton per area is 2 by 3. So I can write 2 by 3 meter square. Here I can write maximum or minimum. If I write, this is P by A plus or minus M by Z. M is 60 kilonewton meter. Z is BD square by 6 now, which is 2 into 3 square by 6. Right. So if you take, this is in meter cube. So if you work out, it will be, if you work out sigma max, I need to use plus. To work out sigma max, use plus. If I to work out sigma minimum in this one, use minus. Okay. So if I work out sigma max, it is 95 kilonewton per meter square, and if you take sigma minimum, it is 55 kilonewton per meter square. Both are I am getting as positive, means those this maximum sigma max and sigma minimum both are compressive in nature, and both are compressive in nature. If you take, this is how the pad fitting is, then sigma max is possible on this side, sigma minimum is possible on this side. This is how the variation is. This is sigma max and this is sigma minimum. This distance, this dimension is already 3 meter, right? Is that okay? This is how we can work out, brother. So can I move to the next problem? Coming to this answer, it is 95 and 55, right? Coming answer is 95 and 55 kilopascal, right? Because it is kilonewton per meter square, means it is 95 kilopascal. 55 kilonewton per meter square means 55 kilopascal. So I can directly pick option A is the correct answer. Is that okay? 95 and 55. Can I move to the next question, brother? Right, Ashutosh Jaina. Can I move to the next question? Yes, moving to the next question. I hope you are able to see the next question. Right. So an RCC square footing of 2 meter length and uniform depth of 200 millimeters is provided for 300 by 300 RCC square footing. The square footing is there. Let me take it as a square footing, and the dimensions of the square footing are 2 meter by 2 meter. Okay, it is fine. This is in plan. So what do you mean by plan? If I am drawing the sketch, if I look from the top view, right, and the effective depth is okay, effective depth is 200 millimeter now, which is 0.2 meter, and they are saying the size, the square, the size of the column is 300 millimeter square. So if you take the size of the column, it is 300 millimeter square now. So maybe this is how the column is, and the size of the column is 300 millimeter, so it is 0.3 meter, this is 0.3 meter. Right. What they are saying, the line of action of the compressive load passes through the centroid of the footing as well as that of column. The applied load PU is passing through, this is the CG of the column, and this is the CG of the footing also. So the applied force is passing through the CG of the column, and it is passing through the CG of the footing also. In such case, there is no extra bending moments will come. That is first and foremost thing. If the magnitude of the load, which is PU, if I take from the front view, this is how I can take. If the magnitude of this PU that is acting here is 320 kilonewton, They are saying what they are expecting. They are expecting you to work out nominal transverse one way shear stress. They are expecting what is the nominal transverse shear stress, which is tau v shear stress, one way shear stress, tau v one way shear stress, which is equal to Vu by. How I can work out that one way shear stress, brother? Always one way shear failure will happen at a distance of effective depth d from the face of the column. If I take this is at a distance of d from the face of the column, if you take this is the hatched area, right? The hatched area, this dimension is already 2 meter, and this dimension I don't know. I am taking it as L. Okay, so how you can work out this VU? The pressure from this VU, how you can work out this VU, man? It is Q naught multiplied times of A. In previous cases, the value of Q naught is directly given. But here in this problem, I need to work out Q naught. How to work out this Q naught? This is PU by the area of the footing over which that load has got distributed, which is 2 by 2 meter by 2 meter. So I can say this Q naught is P by area of the footing in plan. Area of footing in plan. What is this value of this PU, brother? The value of this PU is 320 kilonewton. So 320 kilonewton by area of the footing in plan, 2 meter by 2 meter. So 2 by 2 meter square. If you see, the answer for Q naught is 80 kilonewton per meter square. Okay, this is fine. So if I am able to work out this hatched portion is area A, right? This Q naught is 80 into area A. How I can work out this area A? This is 2 meter by, if I want to work out this length, already this L is already 2 meter. From 2 meter I need to remove zero point 0.3. This zero point 0.3. If I take divide by 2, I am going to get from this to this. So 2 minus 0.3 by 2 minus, from this one I need to remove this effective depth. The effective depth is already 0.2. If you do this one, the value of this L is 0.65 meters. So if I want to work out this area A, hatched portion area A, the hatched portion area is 2 meter by 0.65 meter. And this 80 is in terms of kilonewton per meter square. So let me write here. This is directly kilonewton per meter square. So if you work out this here, value of this VU, the value of this VU is directly one not the value of this VU is directly 104 kilonewton. After I work out this value of VU as 104 kilonewton. Okay, but they are not asking, the question is this VU. They are asking, the question is one way shearing stress. How you can work out the one way shearing stress? VU by, I can say it is acting over a width of 2 meter by effective depth DC. Right. So I can say it is directly I can say B times of DC. Critical section, depth of the depth of the footing at critical section, effective depth of the footing at critical section, that is DC, right? So in such case, how I can work out tau v, one way shearing stress, which is Vu is 104 kilonewton divided by the width is, what is that width? 2 meter by DC, effective depth at critical section. What is the effective depth at critical section? The effective depth at critical section DC, it is which is D or DC, it is 0.2 meter. So if you take this value in meter square, you will end up with this answer called 260 kilopascal, because it is kilometer per meter square. If I want to write the same thing in terms of megapascal, it is 0.26. I can say megapascal. I can write 0.26. I can write megapascal. This is how we can work out. By this we completed footings, brother. Right, the models, all the models on footings we completed. Let me directly move to the limit state of compression, which is columns. I mean, for this one, the option is option A we can pick, right? So before I start columns, I just want to convey, if you are a serious aspirant of GATE or ESE, then definitely I can recommend you guys with this paid course, which is happening in Unacademy Learning app. to get 10% discount for paid courses, either on plus course or an or iconic course. To get 10% discount, you are bound to use this code VT10 in an Academy Plus platform. For plus course, the cost for 12-month subscription after 10% discount is 27,225, and for 24 months, the cost after 10% discount is 39,600. So please be aware of this, right? If you're a serious aspirant, I can recommend you guys this one definitely. And shall we start about these columns, brother? Is that okay? We completed footings and we are moving to columns. So coming to columns, so I hope you know what is a column, brother. Yes, what is a column? Column is a structural element which resists the external loads by axial compression. Column is a structural element which resists external load by axial compression and by flexure. Some people say why you are mentioning for flexure. I hope you know the definition for strut. What is strut? Strut is a pure compression element. In strut, the resistance to applied loads, the resistance to external loads is purely by axial compression. In strut, resistance to external loads is purely by axial compression. Generally, if I want to say in the single way, the compression members in case of rigid jointed structures are columns. Compression members in case of portal frames are rigid jointed structures or columns. When what we can say about strut, it is these are the compression members in case of pin jointed structures. Compression members in pin jointed structures, like pin jointed structures like truss. Now, in case of this column, they are saying about rigid jointed structures. Example for rigid jointed or portal frames. I can say our regular building frame. In regular building frame, if you take this is a framed structure. If you take a column, maybe if you take this column here, maybe this is an AB column. If you take the free body diagram of this column AB, this is A, this is B. In addition to axial compression load, one second. In addition to axial compression load here in this way, there are bending moments are also possible. Bending moments at A, maybe I can write this as MAB. The bending moment at B, maybe I can write as MBA. And to resist this bending moment, definitely shearing forces will also come. So that means in these columns, there are bending moments, flexural moments are also possible. But whereas in case of struts, only axial compression forces are possible. That is the difference between a column and a strut. General, Generally, in case of our RCC structures, it is portal framed structures. Na? So generally, we are talking about these columns only. Now, can I rub the screen? Now coming to the basic definition, sir, if I want to classify the columns, what is the parameter I need to say you? So coming to the parameter to classify the columns. Columns are columns in limit state of compression. Columns are limit state of compression. I am teaching by limit state method. guys, all these what I can say clauses. And coming to slenderness ratio, based on this parameter of the slenderness ratio, we can classify the classification of columns. So coming to the slenderness ratio, which is called as lambda, which is nothing but the effective length, maybe I can say LE, effective length by least lateral dimension. Generally, the slenderness ratio is effective length by minimum radius of gyration. This is the actual way of defining slenderness ratio. But for RCC structural elements, minimum radius of gyration for different rectangular sections or circular sections, or maybe for different eye sections, that we don't know directly. That those the minimum radius of gyration for RCC structural elements are not directly available in tables. So that's the reason why, to simplify our analysis of this slenderness ratio in an easier way, for RCC only, the simplified version of this slenderness ratio lambda is effective length LE by least lateral dimension B. So if I take the column as in this way, maybe one is 450 millimeter, another one is some 250 millimeter, and suppose certain length is there. I don't want to comment about the length. Now for this column, what is the least lateral dimension? What is the least dimension in the column? The highest dimension is the length. Next highest dimension is this 450 millimeter. The least dimension is 250 millimeter. So this 250 millimeter will be, in this example, that will be the least lateral dimension. Least lateral dimension. Right. So coming to this one, so how the compression members are classified. So if I want to classify the compression members, right? How I can classify the compression members? The classification of compression members were given as, if the slenderness ratio of RCC sections L by B, I mean effective length by uh, effective length of that compression member by least lateral dimension. Least lateral dimension. If effective length of that member by least lateral dimension is less than or equal to 3, then in such case it is pedestal. What is this pedestal? Pedestal is a form of compression member. Compression member in case of stepped footing. In case of stepped footing, if you see, the compression member in case of a step foot footing is nothing but a pedestal, because for pedestal or for footings you can say that footing is under compression, no doubt at all, but its length is very less. That means the length in sense its height is very less. So that's the reason why generally we can call those stepped footings are called as pedestals. Now coming to how we can classify the compression member. One classification I can take as pedestal. Second classification I can talk as columns. When I can say the compression member is called as a column when L by B, I mean the effective length of the column by least lateral dimension L by B is more than 3 and less than or equal to 60, then in such case we can classify that compression member as column. Now again in column, based on slenderness ratio, again the columns are classified into two types. What are the types of columns based on the slenderness ratio, which is about effective length, which we call it as LE or L, or whatever the LE. LE is the best way. LE, right? LE, effective length of the column by B stands for least lateral dimension. For short columns, this effective length of column is more than, if it is ranging from 3 to less than or equal to 12. If it is ranging from 3 to less than or more than 3 and less than or equal to 12, in such case it will come under short column. If the slenderness ratio of the column is between 12 to, I mean, if the slenderness ratio of the column is between 12 to 60, is between 12 to 60, this is 12 and this is 60. In such case, such type of columns are nothing but long columns, right? These are long columns, these are short columns, and these are long columns. Okay, coming to this short columns, if you take these short columns, coming to these short columns, these are short columns. In short columns there are three types of columns are there. Those are axially loaded columns. These short columns in which only it is axially loaded. If this is a column, if I take this column in this way, this is a short column, for example. Another name for this short column is also called as, or we can call again, the short columns are also called as stocky columns. Short columns are stocky columns. Right. Now, one sec coming to this, if you take this cross section of the column, on this cross section of the column only axial load is dominant, there is no bending moment is there, and only axial load is dominant, there is no bending moment is there. In such case, such type of columns are nothing but axially loaded column. So it is nothing but axially loaded column. Now some people will also ask us, sir, okay, what is this is nothing but axially loaded column, how we can define this an axially loaded column with uniaxial bending moment? So after, if I take this is the column, right? On this column cross section, in addition to axial compression load, for example, in addition to this axial compression load, which we people call it as PU, if there is a bending moment is also there, if some bending moment is developing about one axis, maybe the axis may be xx, or maybe the axis may be yy, about one axis, if the bending moment has got developed maybe in this way about yy axis, in such case such type of short column is nothing but axially loaded short column with uniaxial bending moment. So this is axially loaded short column with uniaxial bending moment, it is in this way. Now coming to the third type of short column. Third type of short column is axially loaded column with biaxial bending moment. What is this biaxial bending moment short column, brother? So I hope, if I want to show you that same cross section I am taking, but in addition to axial compression load, in addition to axial compression load here, if the bending moment is developed about y axis and about x axis, if the bending moment has got developed like this, about this and maybe about this, about both the axes, maybe I can call this as my, and the bending, this is my, and this bending moment about axis. Bending moment has got developed on the cross section about two axes. Such type of columns are nothing but axially loaded columns with biaxial bending moment, right? So we can define in that way. Now if you take in these, right, I just want to convey, I had mentioned what is the difference between axially loaded column with uniaxial bending moment, axially loaded column with biaxial bending moment. So the same things are possible even in case of short columns, also, even in case of long columns also. Generally, if you take short columns, the mode of failure, if can I rub the screen, brother? Can I rub the screen? If you please excuse me. Can I rub the screen? I just want to rub the screen. There is all link on the slide. So coming to the mode of failure for the short columns, another name for this one is stocky columns. General, the mode of failure for this short columns is by crushing. For long columns, the general mode of failure of this long columns is by buckling. So because of when you take the column is long columns, right? In such case, when the column is long columns, I can say because of its higher length and because of its higher slenderness ratio, it is going to buckle and fail. What is buckling? If I take a column in this way, if the column is applied with the axial compression load, because of high slenderness ratio, maybe if I take a column maybe in this way, this is maybe 400, this may be 250 millimeter, right? If this is the column is in this way. Now if this column is long column, if this column is a long column, now about which axis the buckling is possible in case of columns, always buckling is possible in case of long columns with respect to weaker axis, always buckling is possible in long columns with respect to minor axis. Now the question is, sir, what is your meaning by minor axis? Not my meaning. I mean general bookish way is what is this minor axis means? So minor axis about which moment of inertia is less in the cross section. That axis is nothing but minor axis. Axis about which moment of inertia is least. Right? That is nothing but minor axis. Now, if you take here, this is the axis about which this is the axis about which moment of inertia is high. So this axis is nothing but major axis. Now about this axis, maybe this is x-axis major axis, or maybe this is ZZ. If I take this is ZZ is major axis. Let us suppose if I take this axis as uh, YY axis. If I take this axis as YY axis, about this YY axis, I can say this is nothing but this is major axis and this is minor axis, because about this axis I can say definitely the moment of inertia is the least. Moment of inertia is the least about this axis. So if buckling needs to happen, that buckling will happen about or with respect to this minor axis. That means it is going to get buckled. Maybe I can say in this way. So about this axis only, this is how the buckling can happen, right? This is how you can see the buckling, right? Now some people will say like, sir, is there any minimum eccentricity for which what is the minimum eccentricity generally that should be considered, right? So I can say generally, basically, if you take any column, practically exactly axially loaded column is difficult, right? So practically applying the axial load is always difficult. So as per IS 456, some IS 456 has given little consideration. IS 456 has given little consideration as long as the eccentricity of the column is less than this minimum eccentricity that is prescribed here. Such columns can be treated as definitely as axially loaded columns. So coming to the minimum eccentricity that is prescribed by IS 456. So what is the minimum eccentricity that is prescribed by IS 456? This is L by 500 plus B by 30 and minimum of 20. Out of these two, whichever is higher value I need to consider. One is 20 millimeter and the other one is L by 500 plus B by 30. What is this L? L stands for unsupported length. So what is unsupported length in case of column, brother? If I take a frame, this is how the beam is going. This is how the column is there. This is how the beam is going here, for example. The unsupported length for the column is this much distance. So between these two, between this length, between length from here to here, there are no lateral restraints. It is the distance between, it is the distance within, it is the length of the column within which no lateral restraints are there. Length of the column within which no lateral restraints, no lateral restraints are there. Such type of things are nothing but unsupported. So I here clearly I can say this is L, which is nothing but unsupported length of column. Right? And if you take what is this B, B stands for the least lateral dimension of cross section. When you take the cross section, if you take in the cross section, what is the least lateral dimension? So the least dimension in the cross section, this is B, for example, this is the least dimension, maybe 200, whereas this is 300. So I can say this is D. So this B, which is equal to 200, this is an example for least lateral dimension for column. I can say example for least lateral dimension column. This is how we can do. Now the question is, sir, okay, in case of short axially loaded columns, where here, in case of short axially loaded columns, when we can consider a column as short axially loaded column, that is the question. Let me rub the screen. Let's see. Can I rub the screen here? Akash Kumar, hi Sarji, I am your grade up student. I miss you. Hi Akash, how are you, brother? I remember you. Hope you are fine, brother. Yes? Yeah. So let me rub the screen. Is that okay, brother? Right. Some people will also ask us, sir, in this short axially loaded column, out of this short axially loaded column, right? When we can call a column as short axially loaded column? The answer is very simple. When eccentricity of the column is less than minimum eccentricity that is prescribed by IS 456, that minimum eccentricity is prescribed by IS 456 in this way. When eccentricity of the column is less than minimum eccentricity and the slenderness ratio, and if slenderness ratio of the column is between 3 to 12. In such case, such type of columns can be treated as short axially loaded columns. So in case of short axially loaded columns, the failure is only by failure is only by crushing. Failure is only by crushing of material in this case. Now, right. Some people will say like some people will also say, sir, if it is a short axially, if the column is a short axially loaded column, the column is short axially loaded column. In such case, people will ask us, our students will ask us, how to work out the axial load carrying capacity, design axial load carrying capacity, right? I can say what, how to find the axial load, design axial load carrying capacity. So the load carrying capacity for the column, which is, if you take an RCC column, brother, I hope you know the RCC column has got two materials are there. One is concrete, which is under compression, and I can say steel, which is under compression, right? So there are two materials are there. So axial load carrying capacity PU, it's a combination of load carrying capacity of concrete, load carrying capacity of steel under compression. What is PC stands for? Load carrying capacity of concrete, load carrying axial compression, load carrying capacity of concrete. How you can say about PSC? It is axial load carrying capacity of compression steel. Load carrying capacity of compression steel. Now the question is, how to work out the axial load carrying capacity of concrete separately? How to work out the axial load carrying capacity of reinforcing steel under compression separately, right? So before I just want to say, to work out the load carrying capacity, axial load carrying capacity of any material, I need to say from the fundamentals of strength of materials. Your SM teacher might have already teach you the strength of the material is equal to uh, strength is equal to permissible stress of material of material in the mode of failure multiplied by the effective area of the material, right? The same thing, the permissible stress is the terminology generally we will use in case of working stress method. What is the name of the terminology of the same permissible stress of the material in limit state method? It is all nothing but strength design stress of material. Design stress of material is the terminology generally that we use in limit state method. So design stress of the material in the particular mode of failure multiplied by effective area of material. This is the basic stuff. Now, how you can work out this design stress of the material? The design stress of the material is equal to, I hope you know, design strength or stress of material is equal to characteristic strength of the material divided by safety factor of the material in that particular mode, right? Characteristic strength of the material, actual failure strength of the material in laboratory divided by a factor of safety of the material in that particular mode, a factor of safety of material. So coming to here, the design stress for concrete, the actual failure strength of the concrete is FC, characteristic strength, divided by factor of safety for concrete in axial compression mode. Factor of safety for to avoid crushing problem of column, the factor of safety for concrete in axial compression is not 1.5, brother. It was made as 2.5. This 2.5 is the factor of safety of concrete in axial compression. Factor of safety of concrete in axial compression. Some people will cry at me, sir, it is 1.5 only, sir. That 1.5 is in flexural compression. This is in axial compression for concrete. For axial compression, the factor of safety for our material partial safety factor for concrete in limit state of compression is 2.5. That in limit state of flexure, it is 1.5. That is different and this is different. Both the modes of failure are different. And some people say this is for concrete, sir. For steel, what is the design stress? The design stress is called characteristic strength of steel. The characteristic strength of steel is Fy, and the factor of safety for steel material in axial compression. What is the factor of safety for steel in axial compression? In flexural tension or in flexural compression, it is 0.87 times of Fy. But to reduce sudden crushing problem for columns, the partial safety factor for steel has got increased to 1.5. So if you write here, how I can write the basic stuff, it is FCK by 2.5 multiplied by area of concrete. That is the strength of the strength of concrete, but strength of compression steel. The permissible stresses in steel, which is Fy by 1.5 into area of steel in compression, ASC. This is how we can work out. FCK by 2.5. If you take this FCK by 2.5, the answer is 0.4 FCK. And if you take F5 by 1.5, the answer is 0.67 F5. So this is the formula that was prescribed in IS 456. How you got that formula directly, brother? You got that formula directly from the fundamentals itself. There is no need to mug up. Just you need to memorize what is the factor of safety for concrete and what is the factor of the safety for reinforcing steel when it is in axial compression. If you are able to memorize just these factors of partial safety factors of metal, this 2.5, this 1.5, this 2.5 is for concrete, this 1.5 is for steel in axial compression. So in such case, you are able to write this formula for short columns, for short axially loaded columns, right? So can I move to the next slide, right? Some people will also ask us, sir, we know you had already mentioned what is unsupported length, but you didn't define what is nothing but effective length, right? So let me define what is effective length. What do you mean by capital L? Capital L stands for unsupported length. It is the length over which the column has no lateral support. That length is nothing but unsupported length. In your previous slide, two slides before, I had mentioned the unsupported length with the help of a pictorial view or sketch also, right? Now I just want to work out what is the effective length, LE. How you can define the effective length, LE? It is the distance between points of two successive two adjacent contraflexor points. Two adjacent contraflexor points are two zero bending moment points. Is that okay? So if I just take, for example, if I just take if I take one, this is a column. On one side of the column, for example, let me rub this one. On, let us suppose, if I take on one side, this is one side, right? This is a column. This is a hinge, for example. This is a hinge, for example. So both the ends are hinged on both the sides. Okay. Now the question is, both the ends are hinged, in such case, when I apply a load here in this way, when I apply a load here in this way, and both the ends are hinged, if you take the bending moment diagram, the bending moment diagram is, there is zero bending moment point is here, and there is zero bending moment point is here. So if I want to draw the sketch of bending moment diagram, maybe I can show the diagram of this bending moment diagram. I can say, because of this one, if the deformation is in this way, the deformation is in this way, in such case I can sketch the bending moment graph. This is zero bending moment point, this is zero bending moment point. Maybe I can show, this is how the bending moment sketch is. This is the point of zero bending moment, this is the point of zero bending moment. The distance between two adjacent points of contraflexor or zero bending moment points, that distance is nothing but effective length. So in case of hinged and hinged, generally this effective length is taken as one time. This is actual unsupported length is L. So it is one times of L. For example, if I had taken one end is fixed, another end is fixed. In such case, when a compression load is applied, for example, now when the beam is failing in buckling mode, in such case, this is the deformation sketch of that column, right? Clearly you are able to see. So from here, for this side, the tension is on this side. From here to here, I can say the tension is on this side. For this side, the tension is on this side. If I just draw the qualitative diagram of bending moment diagram, qualitative bending moment diagram, I can show the qualitative bending moment diagram. Like, this is the tension is on this side. Now I am drawing the bending moment diagram on the tension side. This is for this side. For this side, the tension is on this side. For the middle span, the tension is on this side. If I just cover these with the help of straight line, you are able to see, this is the point of contraflexure, this is the point of contraflexure, this is the point where the bending moments are changing its sign. So this distance is nothing but definitely this distance is nothing but effective length. This distance is definitely, it is nothing but effective length, right? So now, okay, I hope you might have seen this effective length concept directly at the times of columns in your strength of materials also. Some people will say like, sir, okay. Now the question is, sir, is there any other clauses were prescribed in code of practice? Yes, there are other clauses were prescribed. In case of circular column with helical reinforcement, I hope you know a circular column with helical reinforcement. In case of circular column with helical reinforcement, this is how the helical reinforcement. In helical reinforcement, some continuity is there, right? In helical reinforcement, continuity for confinement of longitudinal reinforcement exists. Reinforcement, longitudinal reinforcement for column exists. So when there is a helical reinforcement which is having certain continuity, so because of continuity, if I takes, it is very simple. If you take some bars, like these are the bars, when these bars are having these bars are tied, these bars are held in position with a confinement with the help of this helical reinforcement, then in such case this load carrying capacity of this column will also get increased, right? So in such case for circular column, I can say as confinement increases, the axial load carrying capacity, axial load carrying capacity increases. Now, what is the percentage for axial load carrying capacity for this circular column in case of a circular column in short column? I need to increase the axial load carrying capacity. So if I use a circular column as a short column, and in such case the axial load carrying capacity is increased by 5%. Previous axial load carrying capacity is always this much. This is already given as formula. The load carrying capacity of a short column. This is load carrying capacity of concrete plus load carrying capacity of compression steel. Okay. In addition to this one, I need to multiply this with the help of a factor 1.05. Already this is 100 percentage. If I increase by 5 percentage, 100 plus 5, what is the percentage? 105 percentage. 105 percentage of what? 105 percentage of this. What is 105 percentage of this value? 1.05 times of this value, which is 0.4 times of FCK into area of concrete. So like that we can mention. Now if you take here FCK is grade of concrete, everybody will mention. Some people will say like, sir, how to work out area of concrete? Area of the concrete is gross area of the cross section multiplied by minus area of steel in compression. This is how we can work out the area of steel, area of concrete in compression. Gross area minus area of steel under compression, right? So I just want to show you how this helical reinforcement will be, and why there is no increment in load carrying capacity for circular column only without this helical reinforcement. So this is a circular column without helical or continuity in stirrup, continuity in or without helical or no continuity in tie reinforcement. Here this is an example. Here this is a circular column, and in the circular column I hope you are able to see these bars, maybe 6 bars or 5, whatever that may be. 6 bars are tied together with the help of this helical reinforcement. Because of this helical reinforcement, I can say it has got good confinement. Here less confinement of concrete and longish steel. Here I can say high confinement of concrete and longitudinal steel. So because of which here the load carrying capacity as per IS 456 here in this case for circular column with tie reinforcement. What is the name of this tie reinforcement? With this helical reinforcement, the load carrying capacity is increased by 5%. Increase the load carrying capacity by 5%. In such case, we go, that is possible as per IS 456 clause. Right. So some people will also say like, okay, sir, you had mentioned here what is the why the helical reinforcement is more better? The purpose of this lateral tie or helical reinforcement, what is the purpose of this lateral tie or helical reinforcement, brother? The purpose of lateral tie or helical reinforcement is to support main steel or longitudinal reinforcement. If I want to support main steel or longitudinal reinforcement effectively, these are longitudinal reinforcement. For example, these are longitudinal reinforcement. The longitudinal reinforcement are supported laterally, or confinement is good. So confinement is supporting laterally indirectly means. Confinement means supporting the longitudinal bars of column and concrete of column laterally, right? The main usage of this stirrup or this lateral ties you can take, or maybe this helical reinforcement, either lateral ties or helical reinforcement. The major interest is to give lateral confinement, I can say. So the purpose of this lateral tie or helical reinforcement is to support main steel or longitudinal reinforcement. And out of this helical reinforcement and stirrup steel, helical reinforcement is more effective than this stirrups, what I can say, this lateral tie, than lateral tie. Helical reinforcement is more effective than lateral tie. What is the reason behind that one? Because the helical reinforcement, has got more continuity. Helical reinforcement is more continuous than this lateral tie. Now some people will say like, these are the major important, what I can say, clauses from IS 456 2000. So what are the important clauses from IS 456 2000? What is the minimum percentage of longitudinal reinforcement? The minimum percentage of longitudinal reinforcement, it is 0.8 percentage of cross sectional area. So it is high, I can write 0.8 by 100 times of cross sectional area. If it is B, if it is D, then in such case I can write B into, this is an example how we can write. If it is a rectangular section, if it is a if it is circular section, it is the cross sectional area. It is the cross sectional area of the RCC column in for circular section, like that. Why we need to provide this minimum percentage of this steel reinforcement, brother? If I don't provide this minimum percentage of steel reinforcement, then in such case definitely concrete will get crushed. Failure of concrete is always a bad thing. It is a brittle failure. In order to avoid that brittle failure, in order to stop crushing of concrete, so I need to provide certain minimum percentage of this longitudinal reinforcement to prevent crushing of concrete, right? So some people will say like, sir, what is the maximum percentage of maximum which reinforcement? Longitudinal reinforcement. What is the maximum percentage of this longitudinal reinforcement in column? The maximum percentage of longitudinal reinforcement in column is 6 percentage. 6 percentage of cross sectional area. So 6 by 100 times of cross sectional area I can write. The cross sectional area we can write as B times of D. When the answer is B times of D, we can write when the cross section shape is a rectangle. When it is a circular section, the cross section area formula will be different, right? And why we are providing this? There is a limit for this maximum reinforcement. If you had provided maximum reinforcement more like 50 percentage, then let us suppose you think like at beam column junction. Can I rub the screen? Can I rub the screen here? Please excuse me. Can I rub the screen? I just want to show with the help of a sketch. What is the main problem with this major maximum content on reinforcement? Right? Yes. I just want to show that. Maybe erase all the ink. So let us suppose you take a beam column junction. This is a column. This is a column. And this is a beam. At beam column junction, let us suppose you had provided higher percentage of reinforcement, more than 6 percentage. Like in such case, I can say more than 6 percentage you provided the steel reinforcement. So like the spacing of the reinforcement is very congested, maybe in this way. In beam also you had provided maximum limit. So in such case it is also more congested, especially at this junction of beam column junction, as the reinforcement is more congested, as reinforcement is more congested. Congested means the spacing is very the spacing between the bars is very closer. When the spacing between the bars are very closer, then in such case proper compaction is not possible. Proper compaction of concrete is not possible. When proper compaction of concrete is not possible, in such case, that junction will result in honeycombed junction or more void junction in concrete zone. As more void zones are possible in concrete zone, the failure will happen very easily. Even though the steel is more, the failure will happen in concrete itself. So that's the reason why, to avoid congestion, if I avoid congestion, the failure in concrete can also be avoided. Simple, it is very simple, right? We mentioned the reason for this and we mentioned the reason for this one also. Now coming to, some people will just say like, sir, what is the diameter of minimum, what is the minimum size of longitudinal bar shall I need to use in case of columns? The minimum size of longitudinal bar shall I need to use in case of columns is 12 millimeter. Why I need to provide this minimum diameter of this longitudinal bar? If the diameter of the longitudinal bar is just like very less, in such case, if the diameter is very less, if the length is very more, the length that is available in market is maybe 12 meter. If I had gone for this diameter, maybe this diameter is less than 12 millimeter, in such case L by D ratio will get increased. That is, the slenderness ratio of this bar has got increased. So if there is a problem, there is a chance of local buckling of bars. Buckling of these reinforcing bars are possible. In order to stop such things, especially, the code has asked us to provide the minimum diameter size. Minimum diameter size of longitudinal bar is 12 millimeter. This is just to avoid the buckling of bars. If we don't avoid buckling of bar, that again, that is a problem. And one more thing, let me just rub the screen, shift areas. So coming to the next one, the next one is next specification. This is first specification, second, third. Coming to the fourth specification, the spacing of longitudinal bars in case of RCC column. Let us suppose this is the cross section of RCC column. Let us suppose if it is the cross section of RCC column. In such case, when it is the cross section of this RCC column, now this is 250, this is 450. Generally, people think like just 4 bars are sufficient. Okay, if I had gone for 4 bars, the spacing between these 2 bars will be more than 300. Is more than 300. In order to avoid such stuff, in order to avoid this one, especially the spacing between the 2 bars shall be made such that the spacing between the 2 longitudinal bars shall be less than 300. The spacing between the 2 longitudinal bars is less than 300. What is the beauty in that one? So in such case, example, if the spacing between, let us suppose for this all these 3 bars, generally we generally make a tie reinforcement. One second. We generally make a tie reinforcement in this way. This is how the stirrup reinforcement we will provide. Okay. After we provide the stirrup reinforcement in this way, if the space, there is the proper confinement for the bar here, and here, but there is no proper confinement for this bar and this bar. So that's the reason why, if these bars are provided, if the spacing between these bars is less than 300 millimeter, then in such case you are able to provide between these 2 bars with the help of a hook. Another hook I can use. With the help of a hook, you are going to keep this bar and this bar together with this helical reinforcement or stirrup reinforcement with the help of hook in this way, such that the spacing between these bars has got less than the 300 millimeter, not meter man, 300 less than millimeter. The spacing of this longitudinal bar shall be kept, right? So to provide, I need to say, to provide effective confinement to long bars using lateral ties and hooks, right? Now some people will also say like, yeah, for today, if you see, for today we are just the time is only 5 minutes. So for, if you please excuse me, for today guys, I am just stopping the session. The second part of columns, even with problems and all the stuff we will deal in tomorrow's session, right? And before I end up this session, I just want to convey you one more thing, like if you are a serious aspirant of GATE or ESE or any other competitive examinations, brothers, in such case, I can recommend you guys to use to take this subscription. The subscription is ranging from 1 month subscription to 24-month subscription. I can recommend this 12-month subscription to the students who are in final year. If the students are in third year or second year, I can recommend those guys with this subscription of this 24 months, brother. If you are a serious aspirant of GATE and ESE, I can definitely recommend you take this paid course subscription in Unacademy learning app, right? Especially in Unacademy Plus. So to take this paid course, you need to install this Unacademy Learning app first, brother. And coming to the payment for this 12-month subscription duration, paid course duration of for 12 months, the cost after 10% discount is 27,225. And for 24-month subscription, the cost after 10% discount is 39,600. These are the costs for plus courses. If you want to get a special mentor separately, I mean specially allocated mentor to take care of all your doubts instantaneously on the day itself, a special mentor will be awarded to you if you are able to take iconic course. For iconic course, the cost is a bit higher, right? So this iconic course is very much suggested for the guys who are I can say average or below average students. I can definitely recommend this iconic course. If you are a very good student and if you are able to cope up generally, then I can recommend this plus course itself is sufficient. Now some people will say like, sir, how we can follow you guys in an Academy Learning app? So after you install the Unacademy Learning app, use this link which is given below. You are able to use this link which is given below. You are that link will redirect you guys to my page, and you can follow me. When you are able to follow me in an Academy Learning app, the free content that I had already done in an Academy Learning app, you are able to access. The future upcoming video lectures of mine in an Academy Learning app, you are able to get notified about that. And at the end of each and every free session, you will be given with this PDF notes in that free sessions or special classes. So these are the three advantages when you are able to follow. Some people will say like, sir, okay, sir, this is fine. One second. This is fine. Okay. So I want to tackle in the next coming session. Some people will say like, sir, okay. So I just want to convey one more thing. Every day my class is happening in this Let's Crack Gate and ESC Civil YouTube channel. Every day my class is happening by 11 a.m. I am teaching the structural part completely in this Let's Crack Gate and ESC Civil YouTube channel. Completely in sense, I am tackling the important concepts and I am working out that even with theory and problems. I am both with the help of both. I am working out in this batch. So it doesn't mean like I'm working out all the concepts, the important concepts which are useful, which are definitely damn sure 100% sure. Such type of concepts I am teaching in this GATE 2021 rankers batch, right? One thing. And if you want to take the paid course in an Academy Learning app, full detailed course for GATE 2022 or 2021, either crash course or anything, in such case you are bound to use this code VT10 to get 10% discount. When you are able to use this code VT10, directly shows your trust on me. It shows your trust on me, and it will be and it will be, and all your doubts are redirected to me if you are able to use this code VT10, brother. One thing. And I can say it shows your trust on me definitely, right? Moreover, I just want to convey you like, I already started a Telegram group for you guys to solve your queries, and the name of the Telegram channel is Unacademy underscore Civil Engineer Tilak. If you come down to that channel, if you are able to post your doubts, I will take care of your doubts. I will answer all your doubts. if it is structural engineering questions. If it is a non-structural subjects, the other faculty who are in the Telegram group will answer your queries. And some people will also ask us, sir, how we can get down to that channel? Use the link which is given below, which is Unacademy U capital, Civil Engineer C capital, Engineer E capital, Tilak T capital. This is having with underscores, right? So if you are able to follow this link, you are able to follow me using this link, definitely I'm pretty much sure, like, the future coming videos will be notified to you. You will also able to resolve your doubts also instantaneously, right? And I am recommend you guys this, you are getting this for free of cost. Please share the same video to your friends so that they will also get benefited, at least this free content, right? If they are interested, they can take the paid course. If they are not interested, at least they can take care, or they can use of this free content, at least one thing. And I can recommend you guys to subscribe to this channel, and please press the bell icon so that you will not miss even a single video from this channel. The videos that are going to happen, that are going to come in future, will be notified to you when you press the bell icon, right? So please raise a thumbs up, please share this video, please give very good rating, please give thumbs up, please share this video to your friends so that they will also get benefited, brother. Okay, so thank you. And finally, I want to convey, if you are a serious aspirant of GATE and ESE or any other competitive examination, I can recommend you to use this paid course, to purchase the paid course by using the code VT10, and directly 10% discount will come to you on all the courses in Unacademy Plus platform. Thank you. End of the session. Thank you very much.